Hello, good evening from my side, from Germany to all of you. Thank you for your time. I'm Fana Stepper, Product Manager for PTV Lines, and today I want to show you the newest features we have implemented, ridership calculation in Lines. I may go very fast briefly to those features that we have already implemented to and show you what is the tool for. And just first of all, I show you some theoretical part about what we are going to do with Ridership, and then I just dive into the product and show you and some example what can you do with this Ridership calculation. All right, so PTV Lines, what is it again? PTV Lines, the goal for the tool, the platform we have is to enable efficient and data-driven transit service planning, and then you can evaluate the quality of the services you have designed, and then you can show the insights for the decision makers, for the foundings, and also to the stakeholder, and discuss about the design that you have done. The input that you have is the transit service data as GTFS. If you are already PTV Visum user, you can also import just the Visum file to that. We are very compatible there. And if you have the data, you can import origin destination data, transit demand data, but it's not necessarily to have it. If you have, you can calculate the ridership, of course. As an output, you will have updated transit service data, like the updated GTFS if you have done some changes on that, and you can have the operational performance indicators, KPI, and the costs as Excel file or CSV file. And the third one is the efficiency metrics like passenger miles or kilometer, of course, for those who are living in Canada or other countries having no miles, and the capacity miles. And what we are focusing is today is we are showing the transit demand data and efficiency matrix. Core indicators for evaluated transit services just go to the things that we have already have, but I'm not going to show you today is accessibility. We are able to calculate the accessibility, meaning that you can measure how many people or workplaces or facilities have access to the transit network within specific time. This is good for the Title VI equity analysis, but also for the regional accessibility reports and for the government authorities who need this information. The other KPI is the availability and connections. For that, we have also the connections view that you can see the number of departures per stop. You can see from one stop point which lines are crossing that stop and how good the connection are on that specific stop. The use case for that is, for example, the frequency span analysis could be done with that feature. Cost and operation indicators, you can see the number of vehicles and the cost for each vehicle. And other KPIs, this is good for the cost budget report and estimation. For example, for the US, you need FTA to show it to the FTA or NTD. For the usage is the passenger miles traveled, PMT, or as kilometer, passenger kilometer, and efficiency and cost benefit is for use case of occupancy rates and capacity miles. This is what we calculate now, and we'll show you just later in some minutes to you how does it look like. And the use case is to balance transit service with demand, so you can support fleet and frequency optimization project with these insights. Talking a lot about the demand and the KPIs you get from demand, like capacity miles or passenger miles. Just want to show you what we mean with demand and assignment we do in lines, because this is a very big topic. And um, back to the picture that you know already, maybe as planner, that we have different passengers traveling with different modes. Some of them might take the car, some of them bicycle, walking, or taking transit. And considering all these communities, population, people, and the places they are living and traveling to, depending on the time they are going, you can have different origin destination matrices and build different demand model. What we are focusing on in PTV Lines is the origin destination, meaning that the passengers who decided to travel with transit, and then based again on the time that they are traveling, we will do the assignment of this origin destination to the existing services we have. In other words, imagine that you have different zones and people are traveling between these zones. Let me laser point, here we are. So you have like a matrix here saying that how many passengers you have between different zones. You can have, of course, different times, but only one time. On the other hand, you have your services with different transport service. Some of them are faster, some of them have lower or higher frequencies, some of them needed to be changed, and every day they have different characters. Based on these characters, just turn on the movie. So we spread the people, passengers, throughout the services based on the character that the lines and transit lines have. We consider travel time and number of transfers. We give extra weight to walking and waiting time for transfers, so that we find the most convenient and fastest passes and lines for the passengers to go from one area to the other area. As the result, we will have the passenger flows mapped to the available transit services. And we can compare public transit demand with the current situation of the services. You can also see the effect of the service changes. If you do some things, change the service, you can see the changes in the demand distribution. So if you increase the frequency or make the travel time shorter, you can see that the passengers might take that service more frequent and often. The benefit of the ridership calculation is that you can enable simulation of real-life passenger movements, and you can highlight the strengths and inefficiencies in the network and service that you have. So there are some use cases. Let's go through the use cases we have. One of them is you can use the ridership results and KPIs to redesign routes, to reduce overcrowding. You can prioritize the investment in high demand corridors, like defining BRT, introducing BRT lanes. You can optimize the stop spacing and transfer points. You can also schedule service by time of day and direction. What does it mean? Meaning that you can see which direction people are traveling to and at what time, and you can focus on the direction and improve the services, the frequency and time of the services for that direction. And at the end, this is the benchmark from performance with standard KPIs. So you have on both sides performance indicators and the cost and the ridership, and you can make decisions based on these facts. All right. Just before going to the platform, I just want to tell you what I'm going to do. I have an example in Gainesville. I want to use boarding, alighting, ridership insights to restructure one line. This is route number 20. And I want to see what can I understand from the ridership information and show you how can I change the network to improve the network and the passengers experience. All right. So here we are. This is our platform. I have imported the GTFS feeds here, and you can see the lines here on the map, and on the right side, performance indicators. I have imported also the origin destination data. They are not real origin destination data. They are coming from the training model we had in Gainesville. So it doesn't mean that they have bad services. If you see the results, some strange, I just faked it a little bit. Right. What you see here is the origin destination for different times. I have imported here. And if you're a planner, you can easily see the main corridor. This is the city center and the university. And so most of the travels are happening here in this corridor. You can filter it a little bit out, that you can see also more OD data here. All right, this is what you can see and understand a little bit the movement of the passengers, but what you don't see is that which services they have used. All right, to see that information, I just turn on. So I have run the ridership calculation, and the result of the origin destination data I imported to the platform is that you can see. First of all, the entry, exit, and transfers. What you see here is the average per hour, the average passenger per hour for the whole period you have here. I can also select only one dedicated date, for example, Monday, and change the time here. So you can see that the number of passengers are changing, especially make it a little bit bigger. So you can understand, you see the main hubs here. If I go to each stop, you can see also the exact number of entry, exit, and transfers. It helps you to have the big picture of the main hubs that you have in your city and your network. So make it a little bit smaller. You can see also this information in another way. So this is the total passenger per day. And again, you can see this information for each day. What you can also do is that just jump into one line. This is line 20. We talk about and see the part of the ridership information that we had for the whole network, the dedicated data for this line. I can, of course, change it to the go deeper and show the ridership information for one direction or the other direction. So as you see, this is per direction you have changes. What we can also see is that if I go to the indicators, you can see the passenger miles per week and capacity. First of all, go to utilization. Again, the same view that you have, you can have average per hour. It's showing you the passenger mile and service miles. And this is very important for you to see the ratio of passenger mile and service mile. So if you have higher ratio, means that your services is used. And if you have lower, it means that your service is not used. The capacity is telling you that if you have overcrowding, comparing to the passenger miles that we calculated. So as you see here, for example, here we have high occupancy rate. This is because I can maybe just show you how I define the demand model. So you see that the ridership information per peak or off peak I have imported, and for Saturday, Sunday, I have given another values. They are all fictive, they are not real. So it doesn't mean that we have overcrowding in that city, in that line. It just wanted to show you the differences. All right. This information can be seen for each line or for the whole network, or some lines that you just want to focus, like, I don't know, can filter it and see this information for 2, 3, 4, 5 lines explicitly. What else we can see is the ridership profile. If you go to the timetable, you can see how many passengers are traveling between 2 stops every hour. If you show it in another way, you can see the total passenger per day, meaning that, okay, between these stops, you can see the high rate of passenger. And then if you go a little bit down, you can see that, okay, based on this information, the passengers are not using the whole line, meaning that maybe we have the possibility to shorten the line at some point and make it with different frequencies, just giving higher frequency or bigger vehicles, buses to this part, and change the frequency here with maybe smaller buses. You can also see boarding alighting here. This is the same information that we had on the map, but as in table. Again, you can decide which time do you want to change the frequency based on this information. Okay. What else I could see from the analysis we have here is to see the stops. I want to cut the route there and see if the connection is good enough for my passengers, if they need to change on that. Is it a good stop point? I want to cut the line or not? This is possible by the connection analysis. So I can see for this stop which lines are stopping, which services are stopping at this stop. And then you can see if people can easily transfer. If they have enough transfer time, you can also just click here and go to the service that you have, to the travel and to the trip that you have, and change it to make it easier to transfer for the passengers. But it's not what I'm going to do. I just wanted to show you that, okay, apparently we have good connection here. You can also add another stop to that, so you can see, you can make big picture, adding more lines, because maybe people can just walk from this stop to other stop and go. All right, so I have decided, based on the ridership data that I had here, I have decided to cut this line here in this stop to 2 routes and give more frequency to this part and maybe less frequency to this part, and see if I can have better capacity ratio here. And also if I could decrease the service miles and performance indicators, reduce the costs, that would be great. Okay, let's start. I'm just going to duplicate my scenario without changing anything. I'm already in the duplicated scenario, and I am going to copy the route, just calling it from Rights Union to the University A, the outbound will be the same. Copy to, will be a little bit click here, but it's funny. It's very easy to use. So with A, I want to keep this part till here, meaning that I want to just make it shorter. By clicking on these diamonds, I can make the route shorter. All right. And this one, 1, 2, 3. Nice. Okay, we wanted to stop here. Perfect. So if you see, we have this part here. Now we want to make it shorter from that part. I just need this. All right. Nice. And the same for outbound. All right. Just some more clicks and then we are done. Okay, the last part would be this one. Nice. It's almost finished. Here. Okay. And stop. Perfect. Okay, what you can see here, what I have done is that, so my stop sequence has been adjusted to the route that I changed, and I can also see my timetable here. So you can see that I have this part, the eastern part from Rhodes Union to the university, and all I need is that to set also the travel time, meaning that if I arrive here 6:08, I might to start here 6:15 maybe, so that I can change. Also, I can check it here. If I'm arriving here, okay, that's fine. Maybe this one. Again, here the same story, 7:08. So maybe I should start here 7:15. Perfect. What about this one? Okay, that one is okay. And here we have a small problem. So I will start 10:15. Did it work? No, actually, I wanted to change this one. Perfect. Okay, seems to be okay. So you can do also for outbound actually the same thing. What you can do is also to compare the scenario that you had with the origin one and then see the effect of the changes that you have simultaneously here. I have two more vehicles here. The reason is that I didn't adjust the the starting time of the second part here. So if I do that, I will have less vehicles, but what you can see here is that I have extremely less service miles and costs here. You can have the better overview in the operational cost dashboard that we have. So what you see here is that we have reduced the, as you can see, the costs, but also what I just forgot to do is let me change also the frequency that you can see. Let me see which part was. So this part is the shorter one. I have the frequency of 15 minutes, but for the other part, I wanted to put the frequency of 30 minutes here. This is what I forgot. And for the same, here I want to give the frequency 30 minutes. So you can see also, okay, number of vehicle has been also reduced. All the cost has been extremely reduced. Another thing, just one small change I want to do is that to change the vehicle I have here, because I have the smaller bus here, and I like to give bigger vehicle bus for at least Monday to Friday and Saturday. This is possible here by changing the vehicle. I'm giving 40 feet bus here, and the same thing here. So from Monday to Friday and Saturday, I define the bigger buses. Excellent. So I have one more vehicle here, but as I said, I just need to go to the detail and find out the wrong schedule I had. What you can see here is in the indicator. Now, if I go to the vehicle type, you can see that I have introduced a new vehicle here. And you can see the differences. So here I have 3 more vehicles for the 40 feet bus. I didn't have it in the origin scenario. All these other indicators, you can see the service kilometer, the cost has been extremely decreased, but also service miles has been extremely decreased. Service time has been extremely decreased in my new scenario. You can run the ridership calculation again and see the effect of the changes you have done. I have done it actually. I have copied the scenario and run the calculation. So then at the end, you can compare also the occupancy rates. Let me see if I can just show that to you. So on one hand, we have this one which has been changed, and this one was the origin scenario we had. Just let me see, we had it for each day, and here if I change it to each day, so you can see that originally I had very high occupancy rate here, and this one has been decreased extremely because I gave more bigger vehicles to that services on Saturday, also for the other days. All right. Just one small thing I just also forgot to show is that not only the ridership information and connections help you to decide for the better network, you can also have the big picture if you show all the lines in and not overlapping mode as we have here. So this feature will help you also to see if you have too many lines in one corridor, if you can improve the lines, that you reduce some lines and make the main corridor and feed lines to that main corridor. This is really useful information, and it's not only a JPEG, so we can change based on the zoom level the good visualization, and then at the end you have very good view of that. And at the end, if you are happy with your result, you can also, of course, export. And I don't remember where we have been, but I just select. And then you can say if you want to show all the stops or some specific stops. If you want to show all the lines or some lines, let's show line 20 here. And I might need to change the, so that one is better. Okay, I do the confirmation, and then I can show some specific stops which are important. For example, these two stops that I have changed around, and here, and maybe I want also to show some neighbor or important connectors to that line. And then at the end, if I want, I can also, of course, add from the variant scenarios I have created the other variants. And at the end, I have very nice preview. As a JPEG, I can adjust the legend the way I want and prepare this for my stakeholders or my passengers, or just put it on the website or social media. All right, just some last words. Let's go back to the presentation. I just show you some insights from Ridership, other use cases, other examples, project that you can do using Ridership data is, for example, the capacity planning. As I did, you can adjust the vehicle size, you can define the cost per different vehicle types and see the differences, and then run the Ridership calculation and see the passenger load. You can optimize the timetable based on the the profile. You remember I show you showing the number of passenger between two stops. That is very useful to see the peak hours. The occupation of your vehicles in peak hours is also very good. Service designing, if you determine to define the express routes or new connections, it's also very useful to have this information. If you want to have, again, I told you the infrastructure investment, like extra lanes or changing the stations interchange is also good information. And at the end, you can have performance monitoring, saying that you can compare the actual ridership with the model expectation that you have. So that's all from my side. Thank you very much for being here. I'm very happy to be in this meeting. And if you have any question, this is my email address, and I will be happy to help you. Thank you very much.